Welcome to this video tutorial on how to create your very own debugging system within Clickteam Fusion 2.5. Now, the reason why I wanted to do this video tutorial is because I feel like this is a great way for you to debug your games in Fusion 2.5 as you work on them and as you develop them. You probably know by now that Fusion 2.5 comes with its own debugger, but it's a little bit clunky, takes up too much space, a little bit needless. It's hard to, it slows down the game as well. It's quite a burden when you're testing. You know, you might think, well, why is my game running slow? And it's actually the debugger that's causing more of an issue. It's just because this is a hardcore debugging system, but you can make your own debugging system. If I just run this quick game that I've got set up here, you can see here we've got the debugger, and this is the built-in Fusion 2.5 debugger. So it gives you a few basic specs, such as the frame number that you're on, the time that's elapsed since the start of the frame, and how many frames a second it's running at. You also get by default all your global values and strings. You can see all them, and then you can add objects to it as well. So for example, we could add one of these girls to it, and it'll give us the coordinates. It'll give us the heights and stuff like that. It'll give us the values, strings, what animation's playing, and movement. So it gives you quite a few basic things to choose from. But however, you will notice that over time it will slow down your application, which is not really good for debugging. So the best way to do it is to create your own debugging system. Well, how do you do that? First thing we can do, if we're not going to be using global values or anything for now, we can disable the show debugger under the application properties, so that when we run our application we no longer see the debugger. It's no longer launched with the test game. So what do? Right, well, we've got our basic game set up here. As you can see, I've just thrown together some bits. It's like a little mini RPG game with some girls walking around on their own, and this is our player, which we control with the arrow keys, so we can walk around this very empty looking building. It's got some random mirrors and tables and stuff, but it'll do for what I want to show you. So the first thing that I do when I'm creating a debugging system is I create a new layer here, as you can see, and I position this as the topmost layer all the time, so I can still create other layers if I wanted. I just make sure that I keep this one here at all times on the top layer, so that when I do show my debugging layer, it's always appearing on top and nothing's going to come over the top of it. I can even give that layer a name, and I can call it debug, just like that. So how do we do it? This is how I do it. First of all, I import a backdrop object, and it's usually some kind of grayscale HUD that I'm ready to import in, something like that. So if I just center that in the frame and run the application now, you'll see this is where I'm going to place all my debugging information, and all the objects go behind the debugger. I've made it semi-transparent before I imported it, just so I can see what's going on behind the debugger if I need to. So the first thing we need to do is figure out what it is that we want to debug, but before we do that, we need to be able to flick this debug on and off. So how do we do that? There's multiple ways you can do it. I typically use a flag. So in my game developments, if you've seen in the previous videos, you'll notice I will usually have a game controller object, which is basically an active object which is outside the frame area. It doesn't need to be visible, so I can uncheck visible at start and save background transparent and all that, just to save on memory usage. I don't need any of this. All I need to do is create it at the start. So this is an inactive active object. How's that? It's not really inactive, it's still an active object. It's just not visible on the screen. The user doesn't need to see it. I'm just going to use it to store values and stuff. So if you've seen my previous tutorial on Fusion 2.5 optimization, which you can also find online on YouTube and on the website, you'll see that I tend to use these quite a lot. So I will typically have a I wouldn't even have a value. I can use a flag. I can use a flag to do that. So let's create our events to hide and show the debug layer. So I'll just call it debug layer like that. Put it up here. So the first thing I need to do is create myself a hotkey, what I want to use. So in this instance I'm going to use tab. So when I press tab, I'm just going to toggle flag 0 on the game controller active. Now for this I'm going to need the layer object in, because I'm going to be dealing with showing and hiding the layer. What you can do is you can hide the layer at start, but if you're going to be using the toggle method, in fact, yeah, we can do that. Let's uncheck visible at start so that when we run our application the debug layer isn't visible anyway. So we do a new condition or a new event as well that says if let's do that again. If a flag is on, we can show the layer. Now let's add a secondary condition to this, because we don't want to keep forcing Fusion to keep going over this this event. So what we do is we select a layer by name, and we called it debug earlier on. So we can click is layer visible, like that, and then we can negate that because it's not going to be visible. So if the flag is on and the layer is not visible, then we show the layer. So we do layer by name, visibility show, and we can just type in debug like this. So if I press tab now, you'll see our layer shows. So let's just create another event. This one is going to be if the flag is off and the layer debug is visible, then we need to hide the layer. So we can do that by name, visibility, hide, debug. So now by pressing tab I can show and hide the debug layer anytime I want to. Little convenience there. Right. So what do we want to show in the debug window? Well, you can show anything you want. Let me just delete this layer because I don't really need it right now. And as you can see, that'll still work as it should do by pressing tab. So as you develop your game, you might want to throw different things into there. Let me lock these objects down just so that nothing gets moved while I'm designing this debug layer. So the first thing I want to do right now is I want to track the X and Y coordinate of our player. So I'm going to use a series of strings to do this. So I would pop a string in here, and we'll call it object positions. We'll make it white so we can see it, and we'll make it bold. There we go. So object positions is in. So under the debug layer group, we can create a subgroup and call it update, and in here is where we're going to update the strings. So here's a quick trick as well. Again, going back to optimization, what I could do right now is I could create always and then update the string with the positions of that player. So I would put object X like this, and then plus, and I would string convert, and I would get the X position of, or the X coordinate of the emperor, which is the player which is the player object, and then I can put in something like a separator, and then I can do another one for the Y coordinate, like so. So if I hit F8 and run the game now, you can see now that I've got the X and the Y coordinate of our of our player, which is the emperor. As you can see, as I move the object, it's always updating the coordinates. So you can see how already we're starting to build the debug system and it's coming together. Going back to the optimizational side of things, we don't have to do always. In fact, there's two ways you can go about doing this. If the layer is visible, then we can update the strings. Because if it's not visible, there's no point getting Fusion to update it. Absolutely no point whatsoever. So you can either do it that way, or what you can do is when you toggle whether the layer is showing or not, you can activate the group and deactivate it. So we can update it there, and if we hide the just deactivate that group. So we can do it so that when we activate or press tab to show the debug layer, it'll activate the group, and then if we press tab again while the layer is active to make it invisible, then we can deactivate the group. So this should still work, as you can see the strings there, but when the debug layer is invisible and we no longer need it, it won't update the strings. And that's good, because you don't need to update the strings. If you're not viewing it, what's the point in getting Fusion to render it? There's absolutely no point whatsoever. So it just saves on the overhead for your game, which is paramount, as you will know, especially for mobile. Right, so we've got our positions in. We can do a whole host of other things here. We can do absolutely anything we want. Now, when it comes to the differences between the debugger and a custom debugging layer that we want to create, set aside the the implications for memory and performance. Let's think about what we can do with our own debugging system. Now, the default debugging system in Fusion 2.5 comes with the basics. It shows you the values of an object, the movement, the speed, the animation that's playing, the animation speed, and coordinates. It gives you the basics, but that's about it. You can't really expand on it from there. However, with your own debugging system, you can display any expression that's available to you within Fusion 2.5's events. So, for example, what would be included? What can we include that wouldn't normally be included in the debugger? Let me see. Let's create another string object below. Let me have a look at some strings, what expressions we can retrieve here. So we can get the values, we can get the position, we know that. So you can't get things like this in the debugger. You know, the x coordinate of the left edge of the sprite. You can't do that. Whereas with your own debugger, you can, because you can grab all of these expressions at runtime, so you can get the layer that the object's on. That doesn't display in the debugger. You can get distance with a point, the angle of a vector. There's all sorts. You can check what the alpha blending coefficient is, which is not displayed in the debugger. So you can basically get virtually any expression that you want from the events and from the expressions that you can retrieve. Now, the other thing is, what if you wanted to have your debugger active and you wanted to select a particular object? So you wanted to select this one at first, and then after about 10-15 seconds you wanted to check this one. Well, you can do it by clicking on the object, and that all comes down to scoping in Fusion 2.5. Hopefully before you've watched this video you will know what scoping is in Fusion 2.5, and scoping basically is just a way of telling Fusion which objects to apply actions to, because if you've got one object, multiple instances of one object, there's only one or a particular group of objects that you want to apply actions to, then you need to tell Fusion to do that. And you can do that by scoping down in the condition. So what we're going to do on this instance is we're going to use the fixed value for this. So again, we can use this placeholder active up here, and we can create, let's do it as a string rather than, no, let's do it as a number. Let's stick to the basics. Right, so I will create a value in this game controller, and I will call it debug object fixed. Each object that's active in Fusion 2.5, well, basically any object apart from backdrops, have their own fixed value, and this is a unique number that's unique to that object, so it can never be duplicated. That number, it's a fixed value that's unique to that object. So it can be quite a high number. It's not necessarily 0, 1, 2, 3, 4 or anything like that. It's just a fixed value which can be given to an object. Let me demonstrate that right now. So in our debug, we can create another subgroup of events under the debug layer group and call it select object, just to keep things nice and tidy, nice and clean. So what we would do is we'd do the mouse, user clicks on an object. We'll do a left button, single click, and we'll select the girl. So this is what's a version of the scoping is. As soon as we click on one of the girls with the left mouse button, it will grab that specific object's ID. So how we're going to do that? Well, we're going to place that ID in the game controller value we're just in. So what we do is, it's asking us to set the number, so what we do is we right click on a girl and we get retrieve fixed value, and then we click OK. So let's just put this to the test. Let's create this string object is going to tell us which object is selected, so we're going to call it object selected. In our update section on the always, we do this, we do object selected, and then we do a string convert, and we get the fixed value of the active object we clicked on. So if I press F8 and I run the game now, if I click on this, you'll see 65536, 720906, they've all got their own fixed ID, which is unique to that object. So this means that we can further scope now that we have that object, now that we have the fixed value of the object that we selected. So for instance, we want to update a new string. I'm going to change the color on this, make it green, and I'm going to call it girl position. So at the moment, Fusion doesn't know which girl is selected until we click on one. When we click on one, we store the value in an alterable value, and then we can compare that, so we know what we're retrieving. And this comes down to scoping again. So what we would do is we can do compare to one of the values, which is the one we stored, and we compare it to all the girls that are in our frame. So what Fusion is doing in this condition here is it's checking what value we stored, and the value we stored was the girl we clicked on, and then it checks it against all the objects of that, all the fixed values of that object in the frame, and it goes, oh, this is the girl that matches what the user clicked on and stored before. So we can now use that in our strings. So we can do position X like so, and then when we're selecting the girl here, Fusion will know at runtime which girl to get the coordinates from, because it's going to match the ID that we put in there. Let's try that. So we'll run that, and this green text here, as you can see, when I click on it, it doesn't update all the time. Let me fix that right now. Let's do compare two general values. Let's get the fixed value from there, and let's do that. Alright, so what's happening here is this is order of scoping down in Fusion. What I'm trying to do here is I'm trying to say I'm trying to compare the fixed value to the objects, but I'm not telling Fusion to iterate through the objects first, which is what I should be doing. So let me demonstrate. So if I replace this and I go alterable values, compare to fixed value, and then compare it to the one that we selected, it will then render the event as true. So we click on this one, click on this one, and this one. You can see as I select different objects or different instances of the girl, it will update with the events. It's quite a useful trick to know in Fusion 2.5. It's very handy to know. As you can see, we're still updating the X and Y coordinate of our player whilst keeping track of the girl at the top who's going up the frame. So you can see how easy it is to do this. Now, another useful trick to having a debugger is you can actually tell when events are true also. If you've got a game that's 600 events long, I mean, I've seen some games, I've developed some games that are way over into the thousands of events long. You know, sometimes you might have an event and you don't know whether that event is firing or not. Now, there are a few tricks for you to do and test this, like you can play a sound effect in that event, so if it fires, you know that, and the sound effect plays, you know that the event has become true. But sometimes it's good just to do it in the debugger. So for example, I'm doing all this on a whim, so you'll have to bear with me if I get stuck for an example. An example would be if our player collides with one of these, one of the girls. So let's put that to the test right now. we can do collides with another object and the girl. Simple basic event that you all should know in Fusion 2.5. When the player collides with a girl, what we're going to do? Well, the first thing we're going to do is we're going to stop the movement of our player. But if we want to detect whether this event was true, we can display it in the debugger. Now what I'm going to do is I'm going to create a cooldown period. So rather than do a collision between, we'll stick with the collision between, and what we'll do is we'll set a value for our player. So we can put collided as the value, and then we'll do a cooldown for this. So as you can see, they're both at 0 at the moment. So what we do is when there's a collision between a player and a girl, we're going to stop the movement, but we're also going to set the value of collided to 1. We're also going to set a cooldown to I don't know, maybe 10 frames should do the trick. Basically the cooldown period is it'll set the collided value to 1, it'll set the cooldown to 10, we're going to subtract 1 from the cooldown every frame, and when it gets to 0 we're going to reset the collided. It's just so we can visually see what's going on in the game. So in your debug layer on the update, you'll create a new condition that says is collided equal to 1. Then we can create a new string below, and we can call it events true, and then we can change the string to collided with girl. Then we can do another condition that says if collided is 0, no collisions. Whilst collided is 1, we also want to be subtracting 1 from our cooldown, and then when cooldown reaches 0, we want to set collided to 0 also. Let's run that. So if you're looking at these two green texts here, when I collide with a girl, you can see at the moment it says no collisions. Let's go for this one over here, collided with girl. As you can see, we can collide with the girl and we can test that that event is true. I mean, we can see that anyway because the player's stopping, but what I'm trying to get at here is some events can have, you know, they can have loads of conditions stipulated against them. I've come across it myself many a times over the years where I've been developing game projects, and you have an event that has to have 6 or 7 conditions that are true before the event fires, and when you're testing the game and you've got all these events with lots of conditions in, and something's not working, sometimes you can sit there scratching your head for hours and hours trying to figure out, is this event working? If it's not, why is it not working? And sometimes it's very hard unless you analyse your entire code set to figure out what the problem is. Ultimately you will figure out what the problem is, but it's all about time. How long is it going to take? You don't want to waste half a day trying to figure out why a particular set of events is not working, when you can just visually display stuff on the screen. You can display everything that you need to. Now what you will do, because you're limited in area here, you don't want to have a full window full of debugging information. So you can just change these. I mean, you've got four strings set up here. You know, you could probably fit another 2 going down, and you could probably fit some over here as well. And then, so you can just hide that layer when you're editing in Fusion. So you can carry on doing your game design and whatnot. You never really have to see the layer even when you test the game. It doesn't show the layer. And then when you come across something that's not working, you just press tab and you've got your debugging strings up telling you whatever you want it to tell you. So, and you know that you can change any of these strings at any time, and you can just use in the update group, you can just use conditions to stipulate things. You know, for example, where we do always and we're updating the string, we can just do is the player stopped, and then negate that. So this event basically says, is the player moving? If the player's moving, then update the strings, so that when we move it updates the strings. If we stop moving, it doesn't update the strings because we don't need it to. You can do all sorts of things like that, but that's the basic principle of how you can design your own debugging system in Clickteam Fusion 2.5. There's an accompanying PDF file which I wrote about 2 years ago, which I'll link to alongside this video, so you can download it. It's a little bit different from this video what I've done, but it's a little bit more in depth also, and it just gives you a written tutorial overview of how you can create your own debugging system within Fusion 2.5. But I do highly encourage you to start ditching the debugger, start using your own debugging system. It's going to save you a wealth of time, and it's going to give you a wealth of information that you can't access through the standard Fusion 2.5 debugger.